In this module, we're going to look at the first application of cloud, and that's storage. And storage is an important aspect of cloud because it was there first, and it's still one of the most popular applications for cloud computing. There's a number of different types of cloud storage. We're really going to talk about, right now, just two of those. We'll encounter file systems. They're there. We're not going to go to them first because you're all familiar with them, but we are going to look at object stores. We're going to look at how databases are instantiated on the cloud, and you should know that there are bigger collections called data warehouses, and all of the different platforms have their own version of this, but we're not going to cover that in this course. File systems. So this is no different than the file systems that you're used to. The standard API is POSIX for Unix-derived systems, file systems. You can create, read, write, delete files. You have a directory structure. There's usually command line tools, graphical user interfaces, APIs, all sorts of tools have been developed for file systems, and you're all familiar with them. So using a traditional type file system within the cloud has some advantages. You can directly use many existing programs without modification. So programs that expect it to find a file system are perfectly happy existing in file systems that are instantiated in the cloud. And obviously, file systems give you this hierarchical relationship among data, directories, and files, which we're all familiar with, and more importantly, that users are familiar with, so you can keep this same paradigm going in the cloud. Disadvantages, and this comes out a lot when you are looking at high throughput and many different files being stored, is that there's no real convention concerning the representation of the data and their relationships in a file system, except for the sort of folder or directory type system, and then there's files within that. And this, while it's an advantage in that people know it now and they're used to it, it's a very rigid hierarchical structure, and that doesn't always capture the relationships that you want to capture with your data. And so people have looked beyond file systems to other paradigms for storage. The real problem, though, is that when you get into the cloud, many of the applications in the cloud really scale up. And so you have storage needs that are very large, and file systems don't scale well. They weren't designed with the idea of either extremely large files or an extreme number of files. Neither one of those two things are handled very well by most file systems. And so the problem is that you have to have a way to maintain your consistency as you have multiple processes reading and writing, and you don't want bottlenecks. And often you can have that when you have this real extreme number of files that are being written and read from. So we have a problem in scalability, and often you're going to the cloud for scalability. The other problem is backing up. I mean, this is all part of scalability. If you don't have very much to back up, it's really easy to back up. But a lot of systems, backup systems, are the type that look at backing up file by file. And that's actually very slow. It's convenient-ish when you're looking at your laptop, but even then, when you start backing up file by file, that takes a long time to do. Usually what you want to be able to do is take an entire volume and back it up. And if that's a possibility with your file system, if your file system is constructed so that it's on a disk volume, you may be able to back it totally up that way. The thing is, though, that at scale, backups are difficult, and you run into this all the time, that if you get into I was recently working with, on a system a cloud system, where you didn't have volume backups. It's not one of the public clouds, and it was really difficult to look at having scalable backup for a large amount of data. We had to go to a solution that actually would give us volume backups, but in some of the sort of roll your own clouds, that's not necessarily there. And so what you have a problem with file systems is that they really aren't meant for very, very large data storage. Now, one of the things that the cloud platforms went to was the notion of object stores. So with this, you're really storing what they like to call blobs. So they're unstructured binary objects. So they're usually very large binary objects, and so they're called blobs. So in this way, you don't have a hierarchy, you just have blobs. There is a small hierarchy there, but one of the things that they have done to, if you want to contrast them with file systems, is there's no hierarchy, and you cannot update objects or blobs. Once they're created, they're there. You can delete them or replace them. You can have versioning, but you don't update them. And so the notion of going in and changing a blob, no, if you're going to do that, you're going to delete it, replace it, and then you can actually ask for versioning as well, so you can see different versions of the blob. But there's no notion of updating. This is actually, we'll see, very advantageous when you're looking at performance. So what we have with object stores is a two-level folder file hierarchy where you can create a container, or we'll see with the AWS platform, they call them buckets. And each of these buckets can handle 0 or more objects. And each object is identified by a unique identifier, and it can have various metadata associated with it. But with this idea, the idea is that you have to have a unique identifier. And that means when you're going to name your objects, your blobs, you're going to have to come up with unique names. Now, what are the advantages? Well, the big advantage is performance. This is a simple system, and that's why you'll see these are called simple storage systems, or S3s. And they allow for reliability and performance. Now, the way they really got the performance and the scalability and the reliability was the notion of not allowing modification. Because then what you have is a system that can allow for replication without synchronization. And this is huge. If you want to back up your system, if you want to have multiple versions of an object out there, it's very easy to do because you never have updates. So it's not like when you have object A over in one area and a copy of object A in another area, and you change object A in the first area, you'd have to make sure there was some sort of synchronization to change it in the second. Well, you don't have to worry about that because you're never going to modify. You have to delete, but you're never going to modify. And so it makes this very scalable and very reliable because you don't have to put in the synchronization stage. And with synchronization, you have the need for networking. You have to make sure that you never lose connections. All of that you have to worry about timing. You have to do all sorts of different things. You have to put in locking systems. With object stores, that's all gone. We're not going to allow modification, and so you don't need synchronization. What are the limitations? Well, there's not really any organization very much to this system. You have containers or buckets, and you have blobs, you have objects. That's it. You have to know the object's identifier to access it. And remember, they're unique identifiers, which means sometimes you're going to be naming them things that aren't really all that easy to remember. But it means that you have to know the name. And the other obvious disadvantage or limitation to it is that you can't mounted as a file system. You can't access it with tools that manipulate file systems. And so it's a very different model from what a file system is, but it allows us to get what we probably came to the cloud for, and that's scalability, performance, and reliability. And so just to end this look at what the blob storage model is, you have this simple picture from the online textbook where we're just showing what the model is for an object store. And that's where you have multiple containers. Here we have A and B. And in those containers, you can put various objects. We can see in container B, it has an object. In container A, it actually only has one object as well, but it has 3 versions of that object. And so with most storage platforms, cloud storage platforms, you have to tell it whether you want versioning or not. But if you do want versioning, this is what you're going to get. If you name something with the same unique identifier, it's going to be the next version of that object. And so you can't, because we don't have the notion of updating, this is just a replacement for that other object. So that's really the idea of adding it again with the same name, and that means that it's a different version.